If you drop a heavy piece of solid rock into a pool of water, you expect it to sink straight to the bottom. But off the southeastern coast of India, in the town of Rameshwaram, there are stones that plunge into the water and then simply bob back up to the surface. These aren't hidden away in a lab. You can walk into local temples right now and see these large, flat-topped boulders suspended in concrete water tanks, preserved as sacred relics. For centuries, the explanation for this has come from the ancient Hindu epic, the Ramayana. The text describes an army of monkey warriors building a massive 48-kilometer bridge to the island of Lanka, using boulders that floated by the sheer power of divine blessing. Looking at this Google Earth satellite map, you can actually see the remnants of that structure. Stretching between Dhanushkodi town in India and Sri Lanka lies a chain of limestone shoals known as Ram Setu, or Adam's Bridge. What was long accepted entirely as a matter of faith has recently become an active site for modern marine biology and satellite mapping. Researchers are trying to figure out how a geographic structure of this scale behaves the way it does. To understand the bridge, we have to look closely at the waters surrounding it. In physics, whether an object floats or sinks has nothing to do with its overall weight. It is entirely dictated by its average density. Water has a density of roughly 1 gram per cubic centimeter. If a boulder weighs 2 tons, but occupies so much space that its average density drops below that of water, it will float. Geologists point to a specific type of rock that naturally meets this criteria: pumice. During an explosive volcanic eruption, molten lava cools rapidly. When it does, it traps millions of expanding gas bubbles inside, solidifying into a highly porous, sponge-like rock filled with air. There is another explanation native to this specific coastline. The neighboring Gulf of Mannar is home to pipe corals. These are naturally hollow structures that calcify into lightweight, honeycomb-like formations. So the rocks floating in the temple tanks aren't breaking the laws of gravity. They are leveraging the mechanics of trapped air and porosity, keeping their total density low enough to stay buoyant. There is, however, a glaring geographical problem with the pumice theory. Pumice requires volcanic activity to form, and there are exactly 0 active volcanoes anywhere near the Rameshwaram coast. Furthermore, when researchers examine some of the specific stones housed in the temples, they find that a few are darker, heavier, and significantly denser than standard pumice or coral. They still float, but they defy standard geological categorization. Because conventional geology leaves a few gaps, alternative theories have stepped in to fill them. One extreme example is a concept its authors call atomic genetics. This scientific poster details the core of their argument. The authors claim that the universe's gravity was actively reprogrammed through a process they call quantum entanglement, temporarily changing the physical laws of nature specifically to allow the bridge's construction. Rather than accepting that we might just have missing geological data, some researchers invent entirely new, unproven branches of physics to validate ancient texts. To get real answers, we have to scale up from the microscopic pores of individual stones to the macrostructure of the entire strait. Recently, India's space agency, ISRO, partnered with NASA to analyze data from the ISAT-SAT-2 satellite mission. Because the waters here are too shallow for heavy mapping ships, the ISAT-SAT-2 fired vertical lasers directly through the ocean surface. These water-penetrating photons allowed scientists to map the hidden topography of the seabed with extreme precision. When you pull away the water, the data reveals a continuous chain of limestone shoals, intersected by exactly 11 narrow channels that allow ocean currents to flow through. The optical imagery confirms that right now, this 50-kilometer pathway is 99.8% submerged under shallow water. But local temple records document that this entire ridge was actually above sea level, functioning as a fully walkable land bridge right up until a massive cyclone destroyed it in the year 1480. By firing lasers from orbit, modern space agencies inadvertently verified a 500-year-old historical account of a terrestrial pathway connecting the two landmasses. Looking down the length of this narrow peninsula, you get a sense of the physical scale of the terrain reaching out into the strait. Geologists have taken core samples from the beaches running alongside the bridge. Carbon dating of those sediment deposits places their formation at approximately 7,000 years ago. That 7,000-year geological timeline aligns remarkably well with the generally accepted historical dates for the events described in the Ramayana. This leaves an ongoing tension. The alignment of the shoals is so precise that scientists and historians continue to debate whether the base of the structure formed entirely naturally through shifting ocean currents, or if early human civilizations utilized the existing shoals to engineer a crossing. Ramaswaram sits precisely where empirical geology and human myth overlap. While science can explain the physics of trapped air and map the ocean floor with lasers, the floating stones remain a tangible symbol of that intersection.